Let's continue. So I have three angles that we're going to draw with the given measure in standard position. Okay, and then we're going to determine in which quadrant the terminal side lies. So 210 degrees. All right, this is positive, so that means we're going to go counterclockwise. Okay, so if you think about it, 1/4 turn would be 90, 2/4 turns would be 180. And then 3/4 turns would be 270. So to go 3/4 turns would be way too much. So we know that 210 degrees falls between 180 and 270. So that means it's going to look something like this. Okay, and the only reason I put it closer to 180 is because 210 is closer to 180 than it is to 270, but it really doesn't matter. What matters is that it terminates in the correct quadrant, and this terminates in quadrant 3. Okay, and if I want to draw a negative 45 degrees, that means I have to go clockwise. I'm going to have to swing under the x-axis. Now, here's 0 degrees. If I do a quarter turn, that's 90, technically negative 90 since I'm going this way. So negative 45 has to fall in the 4th quadrant, and it's actually going to be smack in the middle with its terminal side there. Notice that not only is the angle terminating in the 4th quadrant, but I also have drawn this arrow showing the direction of the rotation. Okay, so that has to be there. Okay, we're going to be looking for that. I'm going to be looking for that. All right, and then 510 degrees. So this one's a little wonkier, right? So if I go one full rotation, that's 360. I have to go more than that. So if you're wondering, well, how do I do that? You just keep rotating, okay? And one of the cool ways to figure out where you stop is, well, how much more is 510 than 360? Well, if I do 510 minus 360, I get 150 degrees. So once I go a full 360, I have to go another 150 degrees beyond that. So now I have to keep going. So it's like I'm drawing a swirl. So 150 degrees is going to be more than just 1/4 rotation and a little less than 2/4 rotation. So that means I'm going to end up here. Okay, so it swirls around like a little spiral. And we are terminating in quadrant 2. Now I have it done out here a little bit nicer. So I'll erase this. And there we go. Okay. So that's basically drawing those. Okay. So I use the fact that 360 plus 150 is 510. Now the last thing we have to talk about is coterminal angles. And this last example led right into that. So taking this example, okay, if you notice 510 degrees and 150 degrees both end in the exact same spot. So they are said to be coterminal because their terminal sides coincide. Okay. So if you want to find more coterminal angles, it's really easy to do. All you do with a given angle is add multiples of 360 or subtract multiples of 360, and you'll get more coterminal angles because there's an infinite number of angles that are coterminal with 510. Because I could just keep adding on 360 and 360 and 360, or I could just keep subtracting off 360, subtracting off 360, and all those angles are going to terminate in the same spot. Okay? So that's exactly what I just said. Add or subtract 360 is basically the gist. All right. So now let's see if we completely understand how to do this. It's super easy. All right. Find two angles that are coterminal with 130. I want one of them to be positive and one of them to be negative. Okay. So we know that all I need to do is add or subtract multiples of 360, right? So I'm going to pause for a second and give you an opportunity to find those two coterminal angles by employing that tactic. All right, let's see. So if I just add 360, I get 490 degrees. Okay, so that's one positive angle, that's coterminal. And if I want a negative angle, I'm just going to subtract 360, and you should have negative 230. And that's pretty much it for angles of rotation and finding coterminal angles.